Hello guys. So today we'll continue from where we stopped in one of our previous videos on equipment check. We'll start with the 0-degree probe equipment check. So the idea is this: if I have a UT machine connected to a probe, so this is the flaw detector, this is the probe, this is your coaxial cable, and it's connected. You want to check if this machine, while connected to the probe, is working properly. Because you go for jobs and they tell you, is your equipment calibrated? The client asks you, is your equipment calibrated? Which in most cases is supposed to be done annually. The idea of such calibration is to ensure that these things that we're about to check, that they are working properly. So if we go by the list, we have the first one, which is horizontal linearity. We have vertical linearity, resolution sensitivity, and a beam spread. For the two linearity, most especially, it is a function of your UT flaw detector. But when we now come to resolution, sensitivity, and beam spread, is a function of not only your flaw detector, but also your probe. So, starting with the horizontal linearity, when you say linearity, it means the equipment is linear. If we remember from one of our previous videos, we said if you have a UT flaw detector, it is divided into what we call the criticals. And for most units, it's usually 10. Okay, this is not drawn to scale. It's usually 10, so you have 1 all the way to 10. When you say an equipment is horizontally linear, it means whatever reading is given you on the horizontal scale, because in your flaw detector, your horizontal scale is usually your distance, or in some cases it's time, but mostly your horizontal scale is your distance. It means that if your equipment is horizontal linear, if your equipment horizontal linearity is okay, it means that your distances you will be getting on this axis is correct and equal to whatever amount that is being projected. Let's say on your screen, you are getting 20 mm. And if you calibrate your range properly, your echo should be where it is supposed to be. So let me give an example. If I have, say, this V1 block that has a thickness of 25 mm, if I set my range to 100, I'm using this my V1 block, it means that there are going to be 4 echoes that are going to come out. And the first one should be at 25. The second one should be at 50, all the way to 100, if the equipment is calibrated properly. If the machine is able to do that accurately, it means that the horizontal linearity of that machine is okay. If you look at your UT procedure, you might be told that perform horizontal linearity once a week or every 8 hours or at the beginning of the shift. How often you do your horizontal linearity is basically up to your procedure. However, if there is no procedure, you can check your ISO standard for UT. When you talk about equipment check, they will give you the frequency of checking for your horizontal linearity. So your horizontal linearity is for your distance. Or another name for horizontal linearity is what we call our time-based linearity. So that is the horizontal linearity. For vertical linearity, we are now looking at the vertical axis. And the vertical axis, as we know, is used for measuring the amplitude, for displaying the amplitude. Unlike the horizontal linearity that is linear in the sense that the readings are uniform, for vertical linearity, is usually dependent on what we call the dB law. We know from our formula that our dB, which is our amplitude level, is 20 log H2 over H1 or H1 over H2. Whichever is bigger is what goes on top when you're using this formula. So when you're looking at your vertical linearity, it does not follow your normal linear scale. Rather, it follows what we call your logarithmic scale, which is log. Your linear, if I have a linear curve is like this. If I have a logarithmic curve, it is like this. What is the difference between linear and logarithmic curve? For a linear curve, the values are increasing uniformly. For a logarithmic, initial increments are usually very large, but as you get down, the increment or reduction becomes smaller. But it's usually a curve. What this means is that if you follow this calculation, you see that your dB level will be changing according to this formula. For example, we know that if I have, let's say, 20 dB as my gain value, if I increase it by 6 dB, my screen amplitude is supposed to go up. So we'll practically look at how we check for this. So because of time and the length of this video, we are going to practicalize this first thing before we go to the next one. If we look at the horizontal linearity, what are the steps if you want to check for horizontal linearity? So I'll just do a brief run through, then we'll practicalize it and see how it is done for horizontal linearity. So the first thing you do before you do your linearity, you must perform your range calibration. If you don't know how to do range calibration, I'll talk about it in one of my videos. It simply means you need to set up the equipment, do the necessary input, and ensure that the thickness values you are getting are accurate with respect to the range that you have set. So which means you must have calibrated your machine before you start doing the linearity check. Then the next thing you are going to do is using the calibration block. It depends on the calibration block you are using. Set the range for you to get 10 echoes. What does that mean? So this is a V2 block, 12.5 mm. If I want 10 echoes from this, it's 12.5 times 10, which is 125. Which means I should set the range in my machine to be at least 125. If I'm using my V1 block that has a thickness of 25 mm, it means I should set my range to 25 times 10, which is 250. What does this do? It means that by the time you put your probe on the block, with your range set, you are going to get 10 echoes, 10 distinct echoes. Of course, as you go, the height of the echoes will be dropping as your distance increases. So you pick your range, you set your range. Then when you do that, you need to now start, while holding your probe down, you start checking the distance of each of these echoes. So when you check the distance, you record the value, Now, in principle, if I'm using my 25 mm V1 block, if I get the first echo, if my range calculation is correct, I should be getting 25 mm. The second one, I should be getting 50. The third one, I should be getting 75. The next one, 100, and so on, until I get to the last one, which should be 250. What range calibration check does is this. If I check my first one, I get 25. I check my second one. If the equipment range, not range calibration, sorry, my linearity. If the equipment linearity is accurate, I should be getting 50. But in reality, most times we will not get 50. So there will be some, maybe you get 49.5 or 49.2 or 50.1 or 50.2. You keep getting the variation as you check. So you need to record these values that you are getting. Then the next step you do is calculate the error for each reading. And for ISO, the requirement is your reading should not be, your error should not be more than 2%. For ASME, is a different requirement. ASME is a 10% of your reading or 5% of your range. You can check that out. I will not go deep into that for now. But most times we normally use the ISO. Depending on the project you are involved in, you need to be very sure what your error requirement is. So what do you do next when you have this value? So you are going to have a table like this. Take what you are having 10 readings from 10 echo. So I have 25, 50, 75, 100, all the way to 250. So this is my thickness. Then the readings you got, you need to impute them here to 5.0, 50.2, and so on. Then the next thing you are going to do, you check for the error. How do you calculate error? Percentage error rather. You calculate for percentage error. Of course, before you calculate for percentage error, you need to get the error. So if I'm expecting 25 mm and I get 25.2, my error definitely is the reading I got. Remove it from the original reading is 0.2. Percentage error is the error divided by the original thickness multiplied by 100 over 1. That is mathematics. So you will check your error value. If any of these value is greater than 2%, it means that your horizontal linearity of the equipment is not correct, which means that machine should not be used for working because it's not going to be giving you accurate reading. That machine should be sent back for recalibration. Now, if we demonstrate the horizontal linearity, if you look at this, we are using our Olympus Epoch 650. I have set up the equipment, I have done my range calibration, and I have set my equipment range to 250. If you look at the range here, you'll see that my range is 250. Why am I using 250? Because this block is 25 mm and I need 10 echoes. So if I put my probe on the block, if you look at my first reading, I'm getting almost 24.98. The expectation is for me to get 25, but even if I have 24.98 or 24.97, let's say, okay, we can get 25 from the first one. So we have 25. So in the first one, I'm going to record 25 as the reading that I got. So this is your reading. Now, how do I get to the second one? I take my gates, I go to the second one, from my gate starts, I adjust and I get to my second one. If you look at my second reading now, instead of getting 50, I am getting 50.94. So I'll record 50.94. I proceed to the third one, I get 76.24. If you look at the screen very well, you will see that even before you start reading, you try and count your echoes. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means it's giving you the right echo. As you move down towards the 10th echo, you will see that the amplitude is dropping. So while you are getting, by the time you get to about, let's say, the 4th, 5th, 6th one, where the amplitude would have dropped, please go to your gain and increase gain. Forget about Forget about these ones because you've already seen them. So you continue getting and getting until you get to the 10th one. By the setting of this machine, I purposely made these echoes, added color to it so that you can see each of the echo. You can go to setting and take out the echo. You always see this initial band because we are using a single element probe. So you continue to get all of them until you get to the last one. So what do you do? You get your percentage error, or if you want to do error, percentage error. This is 0. By the time you calculate, error is 0. So the error of this is 0.94. So if you do 0.94 multiplied by 50, we should get a value that is less than 2%. You continue for all of them. After doing all that, you check the value. If they are less than 2%, it means your machine is horizontally linear. Linearity is okay, so that settles it. Some procedures will give you a spreadsheet where you can record this value. Or if you go to certain jobs, you'll be given sheets to do your linearity, check your horizontal and vertical. So that settles for horizontal linearity. Now, if we look at the vertical linearity, another name for vertical linearity is screen height linearity. Earlier on, I told you linearity follows your dB rule, which is your dB is 20 log h2 over h1. Just to give a perspective to this dB thing, if you look at your machine, you will always see a button. As in this case, you will see it as dB. In some other machines, you will see it as gain. Now, there's a relationship between the value of your dB and the height of the echo. So if I'm getting an echo here, if I increase my dB, the echo height should increase. And of course, the echo height is measured based on the percentage of the full screen height. So if I look at this, my first echo is almost at 100% of the full screen height. So which means for every dB value I have, I will have a corresponding percentage full screen height for that particular dB. So seeing whether your echo obeys this dB rule, when you increase or reduce the value of your dB, is what determines whether your vertical linearity is okay. So how do we go about it? You need to set your equipment up. Just basic setup. Range calibration is not necessary. So to do your vertical linearity, you don't have to do your range calibration. But if you still do your range calibration, all good. Then get a single echo. In this case, we have about 4 echoes here. We can use any of them to do our range, our linearity, vertical linearity check. So you don't need to use all of them. Just one is enough. Then what do you need to do? Said you should adjust your gain or your dB value until the echo gets to 80%. In this case, the echo is greater than 80% of the full screen height. The echo is greater than 80% of the full screen height. So which means what do? We bring the dB down until it gets to 80%. So in this case, how do you know? If you are not sure of the exact value, just look at your screen here. There's a point on your screen here where you see percentage of your full screen height. It doesn't matter the equipment you are using, you will always see the value of your full screen height. Now, some people will say, I'm not getting 80 exactly, but if you can get values with around 80, if you keep your hands stable, if you keep your couplant uniform, you should be able to get a stable echo at 80%. So what do you do when you get it at 80%? You record the dB value. So let's say in this case, at 80%, my dB value is 48.1. So at 80%, my dB value is 48.1. So this is the first thing you do. Afterwards, you add 6 dB. If it is at 80% and you add 6 dB, the rule says that if I add 6 dB to any echo, the echo height will increase by 2. So which means if it is at 80% and I add 6 dB, this echo will jump to, of course, our screen is 100%, but in the literal sense, it will jump to 160. So what this first one does for you is to just to confirm that by the time you increase it by 6 dB, your echo should go above 80% of the first response pattern. So if I increase the dB by 6 on the first case, what does that mean? I go to my gain value, my dB, I add 6 dB. If I add 6 dB to this, it will become 48 plus 6 is 54.1. I am no longer going to get it at 80%. I will get it above 100%. That is the first thing. The next thing I do after this first adding of 6 dB, that is adding 6 dB, add 6 dB, or I just say plus 6 dB, it will go above 100%. To show that your equipment vertical linearity, is correct, if I remove another 6 dB now, which is the next step, I will come back to 48.1. And if I do that, this should get back to 80%. The next thing you continue to do is you continue to subtract 6 dB from your dB value until the echo dies down. So which means if I take 6 dB out of this, it will be 42.1. The rule of our dB says that this 80% should go to 40%. If I take out another 6 dB, here it becomes 36.1. This should give us 20%. So, demonstrating it practically, now I'm at 80%. Okay, I go to my dB, I'm not at 80%, I go to my dB, I increase the dB, now I'm at, I'd say approximately 80%. If I add 6 dB to this now, it becomes 54.1. You'll see that it has gone above the 100%. If I reduce by 6 dB, it should come back to 80%. And if I keep doing it, you'll see this echo keep dropping and dropping. The reason why I'm having this variation is because I'm not holding it firm. Now I'm holding it firm. As I'm holding it firm now, you see that is steady. So we keep reducing and you see your dB value dropping accordingly. You continue. By the time I take another 6 dB, I will get to 10% and get to 5% like that. Now, if you look at what I was explaining initially, at some point I was not getting exactly 80%. It is not an issue. That is why we have what we call the tolerance. For vertical linearity, the tolerance is usually plus or minus 3 dB. For ISO, take note, for ISO is plus or minus 3 dB. For ASME is plus or minus 5 dB. So depending on the standard that is guiding whatever job you are doing, note this dB value. So what does this thing mean? If I bring it down to, if I add 6 dB, of course, it's going to go above 100%. We are not going to see it. If we reduce 6 dB, we should come back to 80. What this plus or minus 3 dB means is that I should be getting between 80 plus 3, 83. 80 minus 3, 77. So I should be getting 77 to 83% of my full screen height. If I remove 6 dB and I'm at 40, plus or minus 3 dB, it will be 37 to 43%. So it's not, you don't necessarily need to have a 40% full screen height. But if you are getting between 37 to 43, it means that your vertical linearity is okay for the equipment. The same with 20%, which means 17 to 23. So you record these values and check for this, and if there is any error, if the values are going outside of this range, it means that your vertical linearity of your machine is not good. So you have to send it for calibration or reset, as the case may be. So that is just a summary of how you do your vertical linearity.